All right, so we're going to talk about the second half of chapter 2, which is distributions and showing if two variables are independent. So it's being able to compare two variables and see if they're independent, if there's a relationship between them, kind of, I guess. Contingency table, it shows, I don't know why there's a weird thing on my screen, but it shows data of two variables. Where did it go? At once. So you're able to see, it's basically a table. I mean, you've seen these. We'll show, you can look at it on the back if you're curious what it actually is. The marginal distribution, we're going to find that it is the percents of the row or column totals. Basically, it's the percent, oops, I don't want that one. It's the percent of each category. It's like basically what we did in the pie chart and the bar chart, the relative frequency that we found for a single variable. That's what the marginal distribution is. It's finding that for a single variable off of your contingency table. All right, the conditional distribution is a little bit different. This one is finding a percent. So both of these are percents. So finding a percent based off only the row or only the column. Not the total. All right, so when you're finding a marginal distribution, you're still dividing each row or column total by the total of the table. The conditional distribution, you're not dividing it by the total of the table anymore. And we'll do an example that will talk about that. Independence is that there is no association or link. A lot of times we talk about one causing the other, that sort of thing, but there's no association between the variables. Okay, and then Simpson's paradox is using, this really has nothing to do with what we're going to talk about exactly, but is using unfair or silly averages. Like if you're talking about averaging shoe sizes, unless you're talking about a single gender, if we talked about the class average shoe size, it would mean nothing, all right, because women's shoes are measured differently than men's. Or if you're talking about the average color of something, like that doesn't even make sense because you can't average categories. So that's Simpson's paradox. All right, so let's do this example. So a survey of our autos parked in student and staff lots at a large university classified the brands by country of origin as seen as in the table. So this side of the table is the make of the car, whether it was made in America, Europe, or Asia. And then this part is students versus staff. So who drives the car, students or staff? So we have two variables, the category of the person, so are they a student or staff, and then the category of their car, what the make of the car is. So we're going to find several percents. This is kind of the same thing as finding probability for the most part, but we're going to answer a bunch of questions. We're going to find the marginal distribution, a conditional distribution, and then we're going to talk about independence, which relates to the conditional distribution. All right, so A, what percent of all the cars surveyed? Oh, one thing that might be helpful to do right away if they don't do it already for you is to find your totals. So it may be helpful to go ahead and total across and up and down to get those totals because that's just going to make life a little bit easier. So if we add 107 and 105, that's 212. That's the total number of American cars. Total number of European cars were 45. And total number of Asian cars was 102. And then if we total the number of students, there are 195 students at whatever school this is at this university, at least ones that drove. And then staff was 164. And then the total of the table, these should add to the same number as these, all right? So you don't want to add all of these numbers together. You could add all of these numbers together if you wanted to. But the total of the table is 359. Okay, so it's helpful to know those totals. Okay, so A, what percent of all the cars surveyed were foreign? So foreign would mean not American because we're in America. So For our numerator in our percent, in our fraction to get our percent, we're going to add these two together. So we're going to have 147 divided by the total number of people / cars, which is about 40.9%. You can report this, I mean, it specifically asks for a percent, but if it just asks what's the proportion that we're foreign, you could report it as a fraction, you could report it as 0.409, or the percent if you like. B, what percent of the American cars were owned by students? All right, so now this is getting at kind of a conditional distribution here, because we're limiting it to just American cars. All right, so 107 students own American cars. If we want to know the percent of American cars, we're going to take it out of 212. All right, so it's out of 212 instead of 359 because it's the percent of just the American cars. All right, so that's about 50.5. So about 51%. What percent of the students owned American cars? So what percent of the students owned American cars? So this is kind of the flip side of this one. 107 students owned American cars, and there are 195 students. So we divide those and you get 54.9%. All right, D, what is the marginal distribution of origin? So this is essentially if we did not have a contingency table or a two-way table like this, if we just had, American 212, European 45, Asian 102, that's what this is asking you to find percents for. Okay, so origin, you're taking the row total and you're going to find the percent with that in the total of the table. All right, so American is 212 divided by 359, which is 59%. European is 45 out of 359, which is, where did it go? 12%. And then Asian is 102 out of 359, which is 28%. Okay, so that's your marginal distribution. We could also do the marginal distribution of person status, I don't know, person rank on campus, I don't know, and find, 195 out of 359, 164 out of 359. So we could do that as well. E, what are the conditional distributions of origin by driver classification? Okay, so what this means is we're finding the distribution of origin. So we're going to find the percents of just the students and just the staff. So we're going to take it one thing at a time. We're going to do the percent of each make of car out of just the students, and then the percent of each make of car out of just the staff. All right, so that's how conditional is different from marginal. Marginal takes it out of the whole table. Conditional is going to take it out of just a row or just a column. In this case, we're doing columns. So for students, we would do 107 out of 195. That would be American. Oops, I forgot to label it. European would be 33 out of 195. And then Asian would be 55 out of 195. And you'd get percents for those. I do in the next step because I'm going to use these numbers in part F, but I'm not going to write it right here. Okay, so then we're going to do the same thing for staff. For American cars, we're going to do 105 out of 164. European, so we're limiting it just to staff and just to students. So 12 out of 164, and then Asian, 47 out of 164. All right, so then, and you could get percents for those. So then F, do you think that the origin of the car is independent of the type of driver, and explain? And when it says explain, you need to write out a sentence. Oh, wow, I really cannot draw straight lines on this tablet. Okay. So to answer this, to determine if it's independent, you must use a segmented bar graph or bar chart. And our segmented bar graph for independence is always going to have more than one bar. All right, so I'm going to go ahead and do 30, 40, 50, 60, 70, 80, 90, 100. All right, so this is not going to be the best graph on the face of the earth. But we're going to have, oh my goodness. Oh my goodness. I'll delete the ones that don't work. Wow, I'm really bad at this on the tablet. Everything slants the wrong way. Oops, and I need this to be up to 100. I'll delete all the little lines that aren't supposed to be there. I apologize profusely for this because it's horrible. I can draw so much better in person. All right, so we're gonna have one bar for students and one bar for staff. Okay, probably if I had the lined paper, it would help. So anyway, we're gonna do our little segmented bar graph, and we would need the percents from these. So for students, American is like 64%, so it's right in here is American. And then European is 7%, so 64 plus 7 is like 71. So we'll do, I think that's even a little high. And then this is Asian with 29%. And then we're going to do the same thing for staff. Staff American is 55, so it's down here. And you could basically achieve the same thing by just looking at the percents, but for the AP exam, they do want you to do the bar chart. European is 17, so that's 60, 70, so it's actually about at the same place as the other one. And then Asian is 28. Okay. We gotta label our graph. Okay, so we're gonna title it car make. We're gonna say that's the relative frequency, this is the status, and that's students and staff. And so how do we tell if it's independent? All right, if your percents or your bars, your segmented bar charts, are essentially the same, that means they are dependent. So if your bars are different, that means that they are independent. So independent means there's no association. It means that, in essence, means that your status, whether you're a student or staff, does not affect the car that you buy. So that means the bars should be about the same. All right, they don't have to be exactly the same, but they should be pretty close. Ours aren't. Our European is the biggest difference, and so ours are not. Oh wait, no, the bars shouldn't. Yes, ours are not independent. I get this a little mixed up, so I have to make sure I'm saying it right. Dependent means there is an association. So your status would affect car buying. So presumably the staff makes more money than the students do, so they can afford more expensive European cars, something like that. All right, so the bars should be different. All right, so when you explain, you want to say car, make, and driver are not independent. I'm sorry this video is going a little bit long. Because you need to give evidence from the graph. So 7% of students versus 17% of staff drive European. Okay, so you need to give some evidence of why you say that they are not independent or that they are independent. Okay, and it needs to come from the graph or from the percents at least. All right, our Asian are actually very similar. You could also maybe give the American percents as an example of how they're different as well. But the biggest, to me, the biggest difference was the European. So, so that's how you tell if it's independent or not, is by the segmented bar graph.